Hello, welcome back to this new video for you. In this video we are going to use the two images from the previous video and we are going to perform an erosion operation. In this operation we are going to analyze how we can implement a code in MATLAB and how we can use the inbuilt function from MATLAB. So in this slide I'm going to define the erosion constant for you. So the erosion operation is between the image A and the structural element B. So, and this is the equation. This equation indicates that the erosion of A by B is equal to all set of points C, such that B translated by C is contained in A. In order to understand better this is an example we have here, and this is an object A in the image. We can see the ones over here, all the other values are 0, and we have here the structural element B, which is a very simple row, one column. So the operation consists in moving this structural element around all the image, and depending of the relationship between this object A and the structural element, it will depend the output. So the output is 0 when the structural element displaced to these positions doesn't fit completely in object A. So in this case, for example, we have here the structural element B, and it doesn't contain any part of element A, such the output is going to be 0. And the same happens in this case because it's not completely inside the object A. That's why we have in the definition the inclusion operation. So finally, when this object is completely inside of this of the image A, so the output is 1. Exactly when the structure displaced to that position fits completely into the object A. So the output of the erosion is this, what we are seeing here. Is, as you can see, always the output of an erosion operation, it will be always an image which is shorter than the original image, is smaller than the original image always. Well, this is the exercise we are going to perform in MATLAB. The idea behind this exercise is just implement the morphological erosion operation using defining a function and using these two images we have previously discussed in previous videos. And also we just want to make sure this operation was correctly performed, and in order to check that, we can use the inbuilt MATLAB function from the image processing toolbox, in which we can also perform an erosion operation in order to check if our function was correctly implemented. Just here to highlight, it's important to keep in mind that we need to, in order to obtain an image with the same size of the input image, we need to pad the image with zero values. So on that way we need to pad as many zeros as we require in order to have the same size. In this case is just having just one column and one row from zeros in both sides. It will be enough to have the same result at the end. So let's now to analyze the MATLAB code and to understand better this part. So now we are in MATLAB. So as can you see in these lines I am highlighting, this is the line from the previous video, and now we can see how the images are printed. And in these two lines we have here, we are just making the erosion using an implemented function called erode, and we are using the imerode function from MATLAB. And finally we are seeing the comparisons among two results. So now let's run in the code, and here we have the results. In the first image, here in the first image we have the image. In the second feature we have the structural element, we can see here, and we have here the two results related to erosion. As you can see, both results are equals. So now, what was the operation performed behind the code to analyze, to have these results? Let's analyze them, the code inside the erode function. Okay, here we have this is the code, which is an implementation in which it is assumed for simplicity that the structural element is the size 3 for 3. I mean, we are talking about this structural element, and we have 3 pixels in rows and 3 pixels in columns. So the first line we have, we can appreciate here, we are just extracting the size of the image. In this case, we are extracting this size of this image. We are creating a zeros image of the same size of the original image, and we are creating an auxiliary image, which the name is TIM, in which we are creating a zeros image. But in this case, we have we have 2 more rows and 2 more columns in comparison with the original image. And finally, we are making an assignment in which we are taking from this starting from the second row and to the end column -1 in both, also in x and y parameters, and we are making an assignment of the original image. On that way, we have for example, we have this image, but we are going to have zeros for we have the padded zeros of the original image in both sides, also in this side, in this side, and this side. Okay, and we have this because when we start to run the code, when we start to run the for loop, we are going to have the structural element pixel by pixel, centering, trying to center in the center of the structural element with each pixel of the image. So let's continue with the MATLAB code, and after this operation is performed, we are going to run the 2 for loops in which we have I and j. These are the coordinates of the center of the pixel, which begin each one from 2 and the final dimension +1. And for each iteration, we are creating a block. Each of one of these blocks are the current window. I mean, we are talking about a center block in which, let's, for example, use this image, and I'm going to use this. Okay, so in this case, it's important to notice we have this. I mean, we are dealing with the same size of the structural element, because we have assumed that the structural element has a size of 3 por 3. So on that way, we have the same size, because in the first case, if it were 2, for example, it's gonna be like 1 to 3 and 1 to 3. So we have 3. We have this size in each iteration. So we have this structural element, and we are analyzing exactly the same window, the same block. Let me see if I can run this here. Okay. No, I think I cannot take it. Well, we are analyzing for each iteration this block for each one of these pixels. So what is the operation behind this? We are going to extract the pixels exactly when the structural element is equals 1. In this AND operation, we are just looking for if we have 1 values here in block in the current window and the structural element. And that's final result we are saving, we're storing in block again. So when we have the case in the block is equals to the structural element, in that case we can see that we have a matrix with this same result, so we can ensure that we are inside, that the structural element is contained inside the original image, and in that case we can yield 1 as a result. We can ensure that we are performing the erosion operation. So on that way we just make an assignment here. We just make an assignment with the output variable, which is EAIM, a variable we create with zeros values with the same size of the original image. We are making an assigning of 1. And otherwise, if this condition is not, it doesn't take place, so we just make a 0 assignment. So on that way, we are running this. Let's see if I can expand this. Okay, we are running this image through all the 0 padded image in iteration, but when we have a point in which the pixels of the structural element are completely contained inside the original image, so is the case when we can return 1. For example, in this case, we can see how for these pixels, this pixel here I am highlighting with the mouse, we can see how the structural element is completely inside the original image, and we can return 1. So as we can see, the expected output is this output we are seeing here, okay? Because these are the only 3 pixels. These are the only 3 pixels in the original image in which the structural element is completely contained, and we can ensure that is the output, okay? So I hope that you have liked this video. In case you want to keep continuing, just please subscribe to the channel, and we can discuss about theory and practice about image processing applications and code. Okay, bye bye.